Hi guys, Mrs. Irwin here. We're going to be doing 5.7, the fundamental theorem of algebra, which basically says that a polynomial of degree n has exactly n solutions. Before we get into the lesson, I just thought I'd quantify what I said today about being in Michigan and never wanting to live there or any place that cold. I think this is one place that I would actually go to, an ice hotel. If you look closely, these are hotel rooms, bars, that are all made out of ice. Okay, so I hope I'm louder than the music, and so we're just going to talk about this equation right here. So the first thing I want to say is, what is the degree? Well, this is in standard form, so I know that the degree is this 3 right here. So the degree would be 3, which means my total solution should be 3. We're going to factor and solve this. Well, I can look at it and see that this is definitely not going to group. That's just not going to make a match. So I'm going to go ahead and do synthetic division to factor it. So let's set this up. I have 1, -5, -8, and 48. And I'm going to just pick one of these roots here. I'm going to pick -3, and I'm going to go ahead and synthetic divide that. Bring the 1 down, multiply and put in here, add them together, multiply and put in here, add them together, and multiply and put in here, and add. So we've just verified that -3 is a solution, which would go into the factor x plus 3. Okay, and now what we need to do is remember that this now has gone from a cubic down to a quadratic, so we can now take this and we can factor the x squared minus 8x plus 16, which will factor as x minus 4, x minus 4. Okay, or I can put it in as x minus 4 squared, which means I have a solution at 4 and at 4. So remember, this is a double root right here. So that would be what a double root looks like. A new vocabulary term for you also would be, since there are 2 roots at one point, this is called a multiplicity of 2. That's right, that's multiplicity of 2. Okay, now let's move to this one. Again, let's start with the degree. This is in standard form. And so 3 would be my degree. So I have 3 total solutions. That doesn't necessarily mean that there are 3 real solutions. That's total. And if I look closely, it does look like this might group. So we're going to try to do that. So I'm going to take an x squared out of that first group. I'm going to take a 16 out of that second group. It does group because these match, so my first factor would be this, and my second factor would be what's left. This, obviously, the solution is going to be 1, which is what it looks like right here. That looks like 1. But then this other solution is, if I take x squared plus 16 and set it equal to 0, I'm going to get x squared equals -16. Take the square root. I'm going to get x equals plus or minus. The square root of 16 is 4, and the negative is I. So I have 3 total solutions, 1, 4i, and -4i. Okay, so now we're going to find the zeros of this polynomial. Obviously, it's a kintic, it's degree 5, so it's going to have 5 solutions, but if you look at the graph, which is the graph of this function, there are only 2 solutions visible. But I think you probably can tell that this is going to be a double root. So we're going to go ahead and synthetic divide. I've moved outside of McAllister's, hoping that that music won't distract you. So we're going to synthetic divide. I have a 1, -4, 4, 10, -13, -14. And I'm going to go ahead and pull the 2 off the graph. So I'm going to divide by 2. And I get 2 and by golly, it is a 0. So 2 is one of the zeros, and remember that we have now brought this from a 5th down to a 4th. Okay? I still can't factor that, so I'm going to synthetic divide again, and this time I'm going to use one of the -1s. So I'm going to pull down that 1. I'm going to synthetic divide, and again, -1 ends up being a root, but I can see that from the graph. Okay, so now I've brought this guy down from a quartic to a cubic. And looking at those numbers, I don't think that it's going to go ahead and group. So I'm just going to factor down one more time. So remember that this particular root right here is called a double root. It has a multiplicity of 2 right here. So I know that I have 2 solutions that will be -1. So I'm going to actually divide by -1 again, just because I have a double root. And there we go. There's proof that I now have 3 zeros. I have now brought this down from a cubic to a quadratic. So I now have this quadratic left. I think it's just as loud out here. X squared minus 4x plus 7. And I do not know of any factors of 7 that are going to give me -4, so I'm going to go ahead and do the quadratic formula. -b plus or minus the square root of b squared minus 4ac all over 2a. So this is going to give me 4 plus or minus the square root of 16 minus 28, which is going to be -12 over 2. -12 will simplify as 2I root 3 over 2, and I know that 2 can go into all 3 of my terms, so I'm going to simplify that even lower to be 2 plus or minus I root 3. And then here are the other 2 roots right here, 2 plus I root 3, 2 minus I root 3. So if you count them up, I actually have 5 roots, 5 solutions, which goes hand in hand with my degree right here. Okay, so I'm moving back inside because outside actually is louder than inside. So next question is, write a polynomial of least degree with a leading coefficient of 1 and zeros of 3, 2, and -5 in standard form. So now we're going to write equations of them. So obviously if these are my zeros, okay, it's a degree 3. And we know that we say the function, and I put my zeros into factors. So that's going to be x minus 3, x minus 2, and x plus 5. And I'm going to get that in standard form, so I'm going to multiply those 2 out and get x squared minus 5x plus 6. And now I'm going to multiply these out, and I'm going to get x cubed minus plus 5x squared, sorry, minus 5x squared minus 25x plus 6x plus 30. And if we combine all those like terms, we're going to get x cubed plus, nope, those 5x squareds are gone. And combine like terms, I'm going to get negative 19x plus 30. With a calculator, the way to check this is to go ahead and put this in y1 and make sure that it goes through these 3 zeros. Okay, so we're going to do the same thing. We're going to write a polynomial of least degree with a leading coefficient of 1 and zeros of 2 and 2 plus radical 3 in standard form. But I want you to remember this is a little tricky. Okay, it's not tricky, it's a trick. So whenever the only way for me to get a radical as an answer as a 0, I had to have put it into quadratic formula. So I would have never been able to just get 2 radical 3. Remember, it's going to be 2 plus or minus radical 3. So the zeros of this function are actually 2, 2 plus radical 3, and 2 minus radical 3. So I'm going to actually put them in factors again. This is going to be x minus 2. This is going to be x minus 2 plus radical 3. And this is going to be x minus 2 minus radical 3. So the first thing I'm going to deal with is this right here. And I'm actually going to move those parentheses a little. So I'm going to change this to, and I'm going to move the parentheses to around the x minus 2. So I'm just moving them here. And then I have the plus radical 3. And I'm going to do the same thing over here. Put this as x minus 2. And then plus, whoops, didn't want that. Hold on. Plus radical 3. Whoops, sorry, that should be a minus. Okay, and if you look closely at this row right here, this and this are actually conjugates of each other, right? So this is something plus something, and this is something minus something. So these are conjugates. And if you remember multiplying conjugates, the only thing I need to do is multiply the first and the last. The outsides and insides will cancel. I'm going to multiply the firsts and the lasts. So this x minus 2 is going to come down. If I multiply the firsts here, I get x minus 2 times x minus 2. And then I'm going to multiply the lasts. So that's going to be minus radical 9, which is 3. So I'm going to have x minus 2. I'm going to multiply these binomials out. I'm going to combine like terms. And now I'm going to distribute these to each other. So I'm going to do x times x squared, x times negative 4x, x times 1. Distribute the negative 2, so negative 2 times x squared, negative 2 times negative 4x, and negative 2 times 1. So I get x cubed minus 6x squared plus 9x minus 2. So my function that goes through those 3 zeros is this one down here. And notice the degree is 3 because I have 1, and this really is 2. Okay, so really quickly we're going to do one more. I'm going to let you do this and just show you the math at the end, but I want to pause for a minute and think. The only way to get I in a quadratic is to have a plus and minus I. So my 3 zeros are actually 5, I, and negative I. Sorry, that was a mess. Okay, so go ahead and pause and write the polynomial of least degree with these 3 zeros. So here would be your answer and the work to show for it.